Section 5.1 to 5.3 we're going to do all together, and all three sections are about solving inequalities. You'll see that solving inequalities is just like solving equations, just with a couple exceptions, and we're also going to graph our answers on a number line when we're done. So let's just start with an example. Number 1, solve and graph. So we see 6x plus 9 is greater than or equal to 9 minus 4x. So again, we're going to solve this just like we always would, where we want to get variables to one side and numbers to the other. It'll be the easiest if you always get your variables on the left-hand side, which will make graphing easier in the end. So for this first part, I'm going to add 4x to both sides. Because again, getting the variables on the left-hand side of the inequality symbol will help me graph my answer at the end. So now I have 10x plus 1 is greater than or equal to 9. So now I'll subtract 1 from both sides. So I have 10x greater than or equal to 8. I'll divide both sides by 10. The only time I have to flip the sign is if I divide or multiply by a negative. And in this case, I'm only dividing by positive 10, so I'm going to keep it as greater than or equal to. 8 over 10 is equal to 4 over 5 in lowest terms. So here is my answer. So what this means is any number that is greater than or equal to 4 over 5, if I plug that in for the x into my original equation, this side will always be greater than or equal to this side. So to graph it, I only require you to show the number on the number line. Some teachers require you to show where 0 is at also on your number line, but I only require just the number that you got for your answer. What you need to pay attention to, though, is whether you're going to have an open circle or a closed circle. So if it's equal to, like it is in this problem, so it was greater than or equal to 4 over 5, then I'm going to have a closed circle, meaning I'm going to fill in the circle. So I have 4/5 with a closed circle. I kind of like to think of it as filled in. Then it says greater than or equal to 4 over 5. As long as your x value is on the left side of the inequality, this will tell you which way to point your arrow on your number line. So since this is pointing to the right, I'm going to point this to the right. And this is how I do it. Doesn't mean this is how you have to do it. I just like to draw it above it. Some teachers have you kind of shade in here with an arrow. I think it's easier just to kind of draw it above it. It's really just a matter of preference according to what you want to do. I'll know what you mean whatever way you do it, as long as you do it correctly. So again, always easiest if you get your variables on the left-hand side. Make sure you always reduce your fraction. The only time you flip the sign is if you multiply or divide by a negative, and only show the number that you got for your answer on your number line. Fill it in if it's equal to, leave it empty if it's not equal to. And as long as your x value is on the left-hand side, this arrow will always tell you which way to point your line on your number line. Let's see another example. It just says solve and graph for example number 2. 2m minus 7m minus 4 greater than 1 minus 5n. So just like always, I'm going to combine like terms. So 2m minus 7m is negative 5m minus 4 greater than 1 minus 5m. Now if I move the variables from the right to the left, because it's easier to get the variables on the left-hand side when we go to graph, notice that our variables cancel each other out. So I end up with negative 4 greater than 1. Negative 4 is not greater than 1, so therefore this answer is no solution. So you can just use the empty set symbol. If this had been true, if negative 4 had been like less than 1, if that had been your symbol, then it'd be all real numbers. What this means is if negative 4 is greater than 1 and that's false, it's no solution, meaning there is no number I can plug in for m that'll make this inequality true. There's no number I could ever put in for m over here and m over here that would make this side greater than this side, so it's no solution. Again, if this had been true, then it'd be all real numbers, meaning any number I put into this side would always make this side greater than that side. Since there is no answer, the answer is no solution. There's literally nothing I can graph, so there is no graph for this problem. Let's see another example. Number 3, solve and graph. 10 minus 11d greater than negative 5d minus 4. As I've been saying this whole time, it's easier if you put your variables on the left-hand side. But let's see what happens if you forget and get your variables on the right-hand side. This would be really easy to do in this problem because you see the negative 11d over here and the negative 5d. So it'd be really easy just to add the 11d from the left to the right, because you end up with a positive number on the right-hand side. So you have 10 is greater than, these are going to cancel, negative 5d plus 11d is 6d minus 4. Then I would add the 4 from the right to the left. So now I have 14 is greater than 6d. I divide by 6, so I end up with 14 over 6 in lowest terms would be 7 over 3 greater than d. So now, since the variable is not on the left-hand side, it's on the right-hand side, this does not tell me which way to point my arrow when I go to graph it here. The only time this allows you to point your graph in this direction is if the d is on the other side. So if I want to flip it around, I would have to put the d over here and the 7/3 over here. But when I do that, I also have to flip the sign. Right now, the arrow is pointing towards the D. So if I want to flip it around, I have to have the arrow still pointing towards the D. So this means D is less than 7/3. So I would put the 7/3 on my graph. This is not equal to, it's just less than 7/3. So I'm going to do an open circle, 7/3, and now I'm going to point to the left. So again, if you forget and solve it so that your variable is on the right-hand side, just simply flip it around, but make sure you also flip the sign. One more example, number 5, solving graph. 8y plus 10 greater than 2 times 4y plus 7 minus 3. So the first thing I'm going to do, just because I'm going to solve it like I normally do, I'm going to distribute. So I have 8y plus 10 is greater than 8y plus 14 minus 3. Before I start moving stuff around, I see that I need to combine like terms. So I would have 8y plus 10 greater than 8y plus 11. So again, subtract 8y from both sides. So I have 10 is greater than 11. That is false, so it is going to be no solution. If it had been 10 less than 11, then I would say all real numbers. Remember that double bar R sign. So this is the difference between no numbers working in this inequality and all numbers working in this inequality. So again, if it's false, 10 is not less than 11, it's no solution. If it's true, it's going to be all real numbers. I would write that down in your notes. And once again, there's literally no answer to graph, so there is no graph for this problem. And one last thing to cover, and you should know this from years past, anytime you multiply or divide by a negative, you need to flip the inequality sign. So let me give you an example. If I had 3x is less than or equal to negative 12, I would divide both sides by 3. I am not dividing by a negative. I'm just dividing a negative divided by a positive. So I am not going to flip the sign. But if it was negative 3x is less than or equal to positive 12, I would divide both sides by negative 3. And this time I am dividing by a negative, so I'm going to flip the sign and say x is greater than or equal to negative 4. So again, it is only if you multiply or divide by a negative. That is when you flip the inequality sign. I would make sure I wrote that down in my notes. And that's it. Let me know if you have any questions, and we'll cover all of those in class, and we'll see you then.